Now we're going to look at nuclear power stations. We have an expert who's going to help us with this, and his name is Mr. Simpson. And here he is. This is where Mr. Simpson works. This is his nuclear power station. You can see the large cooling towers in the background. So, this is what happens with a nuclear power station. First of all, stage 1, the nuclear reactor, which is here, produces thermal energy, heat energy, which boils the water in the boiler. Next step, the boiling water turns into steam and drives the turbine. Then the turbine is connected to the generator, which produces electricity. Let's look at the energy transfer processes. In the reactor, you have nuclear energy, which turns into thermal energy. In the boiler, the thermal energy turns into kinetic energy of the steam. In the turbine or the generator, the kinetic energy of the turbine turns into electrical energy. Now you need to know the differences between the moderator and the control rods. And here Mr. Simpson's going to help us again. Now what happens here is that when the nucleus splits, a very high energy neutron is emitted. However, this neutron will not embed in another nucleus, not of the kind that we need anyway, so it will be lost. It will not be used for further fission. However, if you slow it down, then it will be. So basically the neutron collides with the nuclei of the moderator, which in this case is water. It basically, each collision slows down the neutron until it's slow enough to be embedded. So this is the moderator. It moderates the speed of the neutrons. So the moderator absorbs the momentum of the neutron and it reduces its velocity. So the moderator basically moderates the velocity and enables further fission. On the other hand, you have the control rods. What you see here is that when the nucleus splits, 3 neutrons are emitted, but the control rods actually absorb 2 of the neutrons. So that controls the rate at which the energy is produced. So those neutrons that were absorbed can no longer be used for fission. So you can basically control the power production. So you need to know about the moderator, the control rod and the heat exchanger. The moderator. These are usually made of water or graphite. They slow down the neutrons to a speed where they can be absorbed by the next nucleus. And here's a quick sketch to show that. Fast moving neutrons will not be absorbed by these nuclei, so they will not cause further fission. Control rods. These are typically made of boron or an alloy with boron in. They are used to absorb some of the neutrons, so they slow down the rate of the nuclear reaction. So energy is basically released in a controlled way. The last thing is the heat exchanger. This superheated material from the reactor is basically pumped into a heat exchanger. Then, like this, then the thermal energy from this liquid or this gas is passed to water, and then the water is basically connected to the boiler, and that makes steam, and that is used to drive the turbine. So the cool water goes in there, and the hot steam comes out there, goes to the turbine. Here we have a little more detail here. Point 1. We have fuel rods, which are the orange rods here. These are the fuel rods. The control rods go between them. The moderator is the material in which it's all placed, often water. And this section here is the heat exchanger. So what happens here? So the coolant is pumped into the heat exchanger. This is the moderator quite often, which is pumped into the heat exchanger. So cold water is pumped in and superheated steam is forced out at the top. Thank you, Mr. Simpson. Now here we have a demonstration. We have some energy is produced here, but not very much. The temperature is low and the output is low. So what we're going to do is remove some of the control rods. Now, as we remove the control rods, less neutrons have been absorbed, so it heats up further, the temperature will increase, the power output will increase. However, if we move them out too much, it goes above the danger temperature, and we have basically a nuclear meltdown. The temperature gets so high, the walls of the reactor will melt, and we have a nuclear disaster on our hands. So we should have an automatic shutdown, which means that immediately the control rods are embedded between the fuel rods to stop this from happening, provided we have somebody responsible enough to be overseeing that. And here we have Mr. Simpson at work. However, he's somewhat distracted, so he should probably pay more attention to those flashing red lights. Uh-oh. And this is the outcome. Yeah, it's not good.